Let's go through a worked example. Here are the data. So I took sodium carbonate, 2.7448 grams, dissolved it up to give me 250 cubic centimeters of solution, took 10 cubic centimeters of that and needed 23.9 cubic centimeters of the HCl to get to the end point, to get to that color change of the methyl orange. So what I need is, ultimately, I want the concentration of HCl. Concentration is moles per cubic decimeter. I know the volume of HCl, so that's the cubic decimeter. I need the moles of HCl here in order to put into the concentration. Where did the moles come from? Well, those moles were reacted with the sodium carbonate, and so if I know the moles of sodium carbonate that I used, then I can figure out how many moles of HCl that was equivalent to. So let's do that, shall we? First of all, to get moles from grams, divide by the molar mass. And so there are 2.7448 grams of sodium carbonate in this solution, which is 0.0259 moles of sodium carbonate in 250 cubic centimeters. I only took 10 cubic centimeters, so therefore the moles of sodium carbonate that I had in that 10 cubic centimeters, various ways you can calculate this. I like to set up ratios. So in this particular case, and there's multiple ratios you can use, but I've got moles over moles. I know 0.0259 moles of sodium carbonate was equivalent to 250 cubic centimeters. I've got 10 cubic centimeters. How many moles are in that? And that comes to 0.00104 moles of sodium carbonate. So this number here, 0.00104. Now the reaction is, of course, sodium carbonate needs 2 moles of HCl to get all the way to that end point, as I tried to show you on the little titration curve. So therefore 0.00104 moles of sodium carbonate needs twice as many, or 0.00208 moles of HCl. So now I've got moles of the HCl. I know the volume that contain that. Molarity is moles over the liters of solution. So that's the 0.00208 moles over 0.0239 cubic centimeters, cubic decimeters, excuse me. So that's the concentration of HCl, 0.0870 moles per cubic decimeter.